Hello, everyone. I am Jaco Liebenberg. I work for a company called Plentify, and yeah, let's get to this talk. Bit of what we will cover in this talk. So we are a small South African company working in like the energy and renewable energy space. We currently have two products in the market. One that is a controller for a hot water system, or in South Africa we call them geysers, and another that integrates into solar inverters. And if you have a large estate or a large apartment building, with these, and you have both of these, we can do some clever things to help you save on energy. Our current tech stack is the one that you see there. So when we started with this, we knew that we would have large portions of code that achieves business functions that we would need to repeat on multiple of our products. And so let me just get rid of that. And so we wanted to design something where we use some of the design principles behind microservices, where you have these services that you design specifically around certain business functions that you can then easily reuse across multiple devices. But that's about where the analogy with microservices end. Towards this end, obviously, if you have a service, you would need to interact with it somehow. So we came up with these concepts of command channels and event channels, where on a command channel, you can use that to indicate to a service to command it to do something. And the event channel can be used by the service to indicate to the rest of the system that some form of event occurred. Inevitably, you design them to be isolated, but they do need to interact in somehow with the larger system and with other services, and this we call the link layer. It's a bit of an overloaded term, but in this context, all it really is the glue that ties a lot of the microservices together. Obviously, different services can have different events and different commands, and then the way we design the link layer is to be thin and simple, where we use a typical if this, then that type of framework. So if service 1 or event 1 occurred, then call service 2.command 1. Or if service 2.event 1 occurred, then call service 1.command. To make this all a bit more tangible, making it more practical usually helps. So imagine you have a house. You love this house, but when you get home after dark, you usually have the step where you always bump your big toe. One day you were fed up and you went to Amazing Company X and you bought their motion-sensitive light. Now, if they were to implement it using this framework of ours, they would typically have a single motion light service. The service would have an event called motion detected, and it would have a command which you can use to turn on the light. And then the if this, then that statement for this simple application would then be if motion light or motion detected, then call motion light or turn on light for 30 seconds. Quite simple, quite thin. And this worked quite well. A couple of months went by, you bumped into your neighbor and he was quite grumpy and you asked him what's going on and he says, no, there's this light that always shines into his bedroom and in the middle of the night it wakes him up. You tried to explain that it's his cat that jumps over the wall and then your dog gets into it, but in the end you decided to go back to Amazing Company X and you updated the model that you have. This new updated model has an LCD screen, it has a button that you can press that will turn on the light, and then it also has a artificial intelligence camera, because I mean, what application isn't better with AI? And then the whole idea is that this AI will only turn on the light if an actual human is detected. So how would we implement the link layer for this application now? Obviously, our LCD service then has a service where if the button is pressed, it raises an event that says the button is pressed, and it has a command that you can use to tell it to display whatever image. The AI camera service then has a command that you can tell it to detect if there's a human. Don't necessarily want to leave that constantly running because AI is expensive and we need to save trees. So you typically want to be able to turn that on just when you need it. And then if it detects a human, it will raise an event that says human detected. So if you then go through the same process, it would have if LCD button is pressed, then turn on the light for 2 minutes. If motion is detected, then call LCD display image that says something like movement detected. Also, when motion is detected, call the AI camera service and tell it to turn on now and then detect if there's a human. And then a couple of seconds later, when the AI camera detects there's a human, you want to display that image that the AI detected on the LCD screen. And then obviously the main function, if a human is detected, then call the motion light to turn on for 30 seconds. And so this is the framework that we decided we want to use to be able to reuse these business functions across multiple services. All we needed to do was to build it. Now we decided to use Zephyr. It's RTOS. All these services can run nice in their own threads, quite isolated. With West and a couple of clever DTS aliases, we're able to achieve a situation where you can just include it in your West, and all of a sudden that product will now also implement this specific business function which you designed around the service. All that really was left was to design the link layer. Now at this stage, we were a newly formed team with more juniors than seniors, and nobody had any Zephyr experience. I think I knew that it existed, but that was about it. And as most of you probably know, Zephyr can be quite a steep learning curve. So our director of embedded development decided to subcontract to someone that has more Zephyr experience. And Mr. Zbus over there, I don't know if it was because of your Zbus experience or if that was just a coincidence, but we ended up subcontracting to him to help us to get over this learning curve. And then when we explained this architecture that we wanted to achieve to him, he immediately went, oh, but I know something. I know that's something that can help. And so Zbus was quite useful there. I once asked him if he could, in a single sentence, explain to me what the technical challenge is that Zbus helps solve. And what he told me was, the big technical challenge that Zbus helps solve is that of one-to-many inter-thread communication. So if you look at the situation, if you look at the link layer, that's typically what we have. We have these services that run in their own threads. It's quite isolated. That needs to communicate to other services in other threads. What is nice about Zbus is you can define the channel within the service without knowing who will subscribe to it and who will consume the information that is published to it, which is quite nice in our services. So we can design our services quite isolated. We use a Zbus channel for the events and a Zbus channel for the commands. And then this helped. We didn't need to know what will happen in the link layer. That can be defined in the link layer later. And so that's nice. There's 3 different ways you can subscribe to a Zbus channel: a listener, a message subscriber, and a normal subscriber. The listener will use the context of whoever publishes to that channel. So in our design, typically we use a listener that will divert the thread context to the calling server, to the publishing server, so the server that raises the event. And then message subscriber and normal subscriber is typically used to defer to other threads. So if you subscribe with a message subscriber or normal subscriber, the execution will happen in the observing threads. So this thread raised the event, the execution of the command will happen in the other threads that are subscribed to it. The main difference between a subscriber and a message subscriber is that a subscriber will give you the most up-to-date of whatever was published to the channel. So if the thread is busy doing its thing, a couple of events comes in, and you subscribe using a normal subscriber. When it comes back to servicing that subscription, it will only have the latest version of what was published to that event channel, which is nice in certain cases, whereas a message subscriber guarantees delivery. So if you don't want to miss any events, you can use a message subscriber and then obviously pay the overhead penalties for that guaranteed delivery. So let's reflect a bit. This helped us to fully achieve the architecture that we want. We have this nice isolated services that we can design separately, that we're in the link layer with a pretty thin link layer, these pretty thin if this then those statements. We have macros that helps us define them. We can direct the final behavior of the product. And this all worked quite nicely. Going back to the microservice analogy, if you have a bunch of microservices and there needs to be interaction between them, you typically use something like a REST API. You don't have to use a REST API. You can go and design your own bitstream over whatever TCP or UDP connection or anything. But typically, you use a REST API. Everybody knows it. Everybody knows what to expect. Everybody knows how it works. Similarly, we did not have to use Zbus to achieve what we wanted in our link layer. But using Zbus gave us that framework to work in. Everybody knows how this should work. You can go and look what are the commands that are defined on the events, on the commands channel. What are the events that a service will typically be able to give you? And it gave us this nice framework that really allowed us to make our link layer, the code that differs between products, quite thin. And yeah, so some of the advantages we have with this is reusability in multiple bots. We have these services that contain mounts of the logic, all designed around specific business functions that we can just reuse and include in different products quite easily. We have very nice, well-defined separation of concern boundaries across all our services, between services, and this allows testing and maintainability to be much improved. You can test a service on its own, and that's quite nice. Some of the challenges we have with this is we have these repeated struct definitions that we use to define our Zbus channels. And how that typically looks is you would, the first byte would be a identifier of the specific event that happens on that channel. And then depending on what event is published, we union across all of the different data structures that the different events or commands will have. That obviously has some type safety concerns that immediately come up with that. So that's one of the challenges we have with that. And then another is if the data is quite large that you want to send across these channels, that makes it so as the nature of it is, if you need to pass something across multiple services, say for instance the image that the AI service generated, and you need to pass that across the multiple services, then each service, each time you pass it, a new copy of that needs to be made, especially if you're using something like message subscribers. The alternative to that is to not pass the actual data, but you just pass a pointer to it. But now you're in a situation where you, by design, publish something to a channel, and you don't know how many consumers there will be, and you don't know when they will consume the data. So knowing when to free that data or how to handle that also becomes quite difficult. So the safer option is to just pass the full data, full copies of the data around, but that then obviously has this multiplying effect across the stack that you will need to do it. Yeah, so that's some of the challenges we have. And that's what I have for you. Thank you, Mr. Rodrigo. We would love any comment on what we've done, and then we're hiring. Any questions, any discussions? Yes.
Let's say I would love to have an architecture based on Zbus, like a service line. I understand each service needs a thread.
Yeah, so it's designed, we intentionally kept that open. We have services that don't use any threads, and we just use listener subscribers, so we always use the context of the ones that call into them. And then we have other services that use by themselves, like we have a separate work queue thread specifically for that service with a separate thread that does its main processing and all of that. So we intentionally left it open. Whoever designs the microservice can then decide how many threads it needs, what work queues it wants. Yeah. Yeah, so just on that, I did find, however, that the way Zephyr handles their threads, it's quite, they're quite deep. The overhead for different threads is quite low. But yeah, I get your